Okay, so again, let me just remind you, make sure you don't neglect the fact that this is 11B, and you need to go back and review Chapter 11 if you're going to be prepared for your test on Thursday, completely prepared. I'm going to review the second half, 11B, today because that's what we've done, and that will be the majority of the test, but remember, all that stuff in 11 applies in what we're doing, and there'll be some questions from it, so be careful. All right, first question. Let's go ahead and do number 29. You know what? Let's go right to 30. That's a better question for you guys, and I'll save the odd. For those of you that feel like you need extra work, you can work on that odd. You got 5 times the square root of 2 minus the square root of 3, quantity squared. Okay, if you'll stop, and I do want you to stop because I want you to take advantage of the teaching. So again, I'm just trying to get you guys to figure out what to do and see if you approach the problem correctly. So again, hopefully you understand that there are 2 of these, right? It is 2 binomials. You've got to start that way. If you don't start that way, you're going to be in trouble. Again, just watch. Stop writing and just watch. Coefficient times coefficient. 5 times 5 is 25. Square root of 2 times square root of 2 is a 2. Now again, if you want to start with square root of 4, knock yourself out, but it ends up being a 2. Distribute to the back. 5 times a negative 1 is a negative 5. Square root of 2 times square root of 3, I'll multiply those because I know that's not simplifying. On the back end, a negative 1 times a positive 5 is a negative 5. A square root of 3 times a square root of 2 is a square root of 6. Again, I'm multiplying those because I understand. Now look, some of you aren't taking my... Okay, so then on the back distribution, be careful here. You have a negative 1 times a negative 1. That's a positive 1. And then a square root of 3 times square root of 3 is a 3. Again, you might want to write it out, but when you simplify it, it's a 3. All right, so we got to finish off numbers and numbers. That's a 50, and that's a 3. So that's a 53. Negative 5 of them, and another negative 5 of them is a negative 10 of them. And that's where you would have ended up with 53 minus 10 times the square root of 6. Okay? So the point is, on something like this, when you're done distributing and simplifying, see if you can add any like terms. Numbers will add with numbers. Radicals will only add if they're the exact same radical. These were both square roots of 6, so I could add them. Otherwise, I wouldn't be able to do so. All right, any questions on that? Okay, let's go to 32. 32. Again, I'm going to give you time to just get started, and then I'm going to jump in. 32. Okay, so let me pause you. So hopefully when you look at a problem like this, you say, okay, I have a binomial in the denominator. And when I have a binomial, I have to multiply by the conjugate. That should be your thought. What is the conjugate? Different middle terms. So instead of minus, it's a plus. So square root of 3 plus 3 times the square root of 2. By the way, there was no simplifying I could have done ahead. I'm going to put the left one in parentheses. And again, whatever I do to the bottom, I, of course, have to do the exact same thing to the top. And so that's where I'm at right now. As I told you, I do the bottoms first. Now, because it's a difference of 2 squares, and I'm going to think that, I can do the shortcut, only because it's a difference of 2 squares. Front times front. Square root of 3 times square root of 3 is a 3. Back times back. Negative 3 times a positive 3 is a negative 9, but a square root of 2 times a square root of 2 is a 2, and that's a negative 18. So 3 minus 18 is a negative 15. Oh, it's very important that I did the bottom first, because this 3 and this negative 15 can reduce. Again, easiest way, do 3 times 5. By the way, our negative's going to end up in the top. 3's divide out, but that negative ends up in the top. So you end up with negative the square root of 3. That's the best way to do the problem. What does my bottom end up? A 5, because I can reduce. Now I got to distribute. Negative times 1 is a negative. Square root of 3 times square root of 3 is a 3. Second distribution. Negative 1 times a positive 3 is a negative 3. Square root of 3 times square root of 2 is a square root of 6. And that would have been the correct final answer. Negative 3 minus 3 times the square root of 6 over 5. What I find students do, again, you have examples of this. I'm going on to the next problem in 2 seconds here. What I find students doing is, if you don't put the negative in the top in the beginning, then you don't distribute it to everything in the top in the end. Be careful. A negative going from bottom to top, if you distribute it to things that are being added, must be distributed to everything being added. All right, let's do the next one. Go ahead and do 34. Directions say they want the answer both in simplified radical form and then also in decimal approximation. All right, you're trying to find that third side. Okay, again, if I can get you back. So again, you may not be finished yet, and that's fine. Here should have been your thought process. Okay, I got to use the Pythagorean Theorem. What am I looking for? It's always important that you know whether you're looking for a side or the hypotenuse. In this one, it is the hypotenuse. Just a reminder, Pythagorean Theorem is a squared plus b squared equals c squared. That is why c is the square root of a squared plus b squared. Be careful. If you solve for either a or b, it's always going to be the c squared minus the other side. Why? Because you would have had to have moved one of those variables to the other side by adding its opposite, making it negative. And that's why when you solve for either a or b, it's the hypotenuse squared minus. Don't make that mistake. That's a biggie. So this would have been b squared and this would have been a squared. Okay, anyhow. So now you go through and you stick in the numbers. A and b, it doesn't matter. They're interchangeable. Make one of them a, make the other one b. 100 plus 36 is 136. Now I got to go about the simplification process. Me, I'm a divider by 2. Divide this by 2. What do I get? 68. Divide this 68 by 2. I get 34. And a 34 is a 2 times 17. I'm not going to get enough of anything. But what's the square root of 2 times 2? It's 2. And you should have gotten 2 times the square root of 34. Anybody have time to get the decimal answer? What do you got, Eduardo?
11.7.
Yeah, 11.7 if you go to one decimal place. Again, how would you do that? Just punch it out in your calculator. 2 times the square root of 34 on your calculator. Any questions on that? Pythagorean Theorem. Okay, let's go on to the next one. Go ahead and do 36. If you have time, I want you to not only find the distance, but to also find the midpoint. If you have time. Not only find the distance, after that, find the midpoint. First point is 4, negative 5, and the second point is negative 5, 4. If you can't think of the distance formula, you're going to have trouble tomorrow and Thursday. You have to memorize it. All right, again, let me pause you. Take a look up here, please. So when it tells you to find the distance between 2 points, your brain should say basically it's the Pythagorean theorem in a form that allows us to use the coordinates. The distance is really the hypotenuse of a right triangle. But how do you get the two sides? X of 2 minus x of 1 will be the coordinate of one of the sides, so you'll square it, plus y sub 2 minus y sub 1 will give you the coordinate of the other side of the right triangle, and so you square it. Now my advice is always to label your points x of 1, y of 1, x of 2, y of 2, so that you don't make a mistake subbing them into the formula. X of 2, negative 5, minus from the formula, x of 1, 4, squared, plus y sub 2, 4, minus, be careful here, y sub 1 minus 5. You have minus a minus. Negative 9 squared or 9 squared is exactly the same thing. Negative 9 times negative 9 is 81, and 9 times 9 is 81. 4 plus 5 is 9. 9 squared is 81. You have to add these before you try to take any square root. Those have to be added. You can't say the answer is 9 plus 9 or 18. That's not true. The answer is square root of 162. We would look to simplify. This is a 2 times an 81. And I can stop right there. Do you know what the square root of 81 is? 9. So this thing ends up 9 times the square root of 2 would be the simplified answer to that. So you got to know the formula, though. And then midpoint's easy. Add up the x coordinates and divide by 2. That's your x coordinate. Add up the y coordinates and divide by 2. That's your y coordinate. Remember, we're in parentheses. So what is this? 4 minus 5 over 2 and negative 5 plus 4 over 2. All right, the left is negative 1/2 and the right is negative 1/2. And that's the way that one would have ended up. They just like to play on the numbers on that one. The 5s and the 4s. All right, add the x's, divide by 2. It's the x coordinate. Add the y's, divide by 2. Remember the coordinates, use parentheses. All right, try number 42, radical equation. Okay, remember, solving a radical equation, first goal, isolate the radical. Then square both sides, and then finish off by isolating the variable. If when you go to square both sides, if you have a negative result, do you even square both sides? No, you stop and say no real solution. Add a negative 10 to both sides. That will make the left a negative 6. However, when you divide both sides by negative 3 to move that negative 3, you're in good shape because this is now a 2. I am now ready to square both sides. And I end up with x plus 7 equals 4. I now add a negative 7 to both sides, and I get the answer x equals negative 3. Okay? X equals negative 3. How many got that one correct? All right, good. All right, for time's sake, let's go ahead and do 51. Which one of those is graphed? Which one of those is graphed? And then if you can and you have time, try 52. So do 51, and if you have time, do 52. All right, so let me get your attention. The vertex is really the key to a lot of it. So this vertex is 1, 2, 3, negative 3, positive 1. So I know the positive 1 is the k value, so this one has a positive 1. That one has a positive 1. I'm down to E and D. Those are my only two possibilities because those are the only two that have a positive 1 for the k value. Now again, I have to understand a minus 3. Remember, the formula is minus and then the h value, and therefore, hopefully, you chose E. How many had E? Okay, good. So that was E. Before I go on to the next one, I want to show you a few things. So let's take E. What if, in the course of this, there would have been a negative here in front of the whole radical? In front of the whole radical. So nothing would have changed on the vertex. It would still be -3, +1. Now when you stick in a -2, when you get the square root of 1, you have a minus in front of it, and it's a -1. -1 plus 1 would be right here. And this will happen to every point, and that one would end up going like that, if there would have been a negative in front of the whole thing. What if instead of a negative in front of the whole thing, what if there would have been a negative in here, and I'm going to use a parentheses. Okay, a negative in here with parentheses. Could have been a -x minus 3, by the way. What would have happened then? Well, now inside, you'll have to use negative values of x to get it to work. And that one would have gone like that. Okay. A negative inside with the variable makes it go the opposite direction. A negative out inside of the square root mirrors it about the k value. Okay? So negative outside mirrors it about the k. The negative inside with the variable flips it the other direction. Okay? That's how those all work. All right, and so if you had time to do the last one, hopefully you said the square root of x plus 5 minus 3. How many got that correct? All right, good job. So quiz tomorrow, test on Thursday.